This presentation is going to cover the wheel and the axle. So this is the second simple machine that we would have covered. The first is the lever. So the wheel and axle is essentially a lever arm. Well, the wheel is a lever arm that is fixed to a shaft called an axle. Okay, so this would be the wheel similar to what you see on your car, and that wheel is going to be driven by an axle. So the wheel and the axle move together as a simple lever to lift or move an item by rolling. So when we look at a wheel and an axle, so in this picture here, we can see that the lever and how it works in a wheel and axle system. So the fulcrum would be right in the middle here of the axle, and then depending if the wheel is driving the axle or the axle is driving the wheel, that would be representative of the FR and the FE. So for example, in a car, the axle drives the wheel, right? So if the axle drives the wheel, then that would be our force effort. And the force resistance would be the wheel, okay? But let's say that now the wheel is driving the axle. If the wheel drives the axle, then the effort would be on the outside and the resistance would be on the inside, okay? So there are different types of examples of a wheel and an axle. A screwdriver is one example that we typically don't really think about, but when you look at it head on, you can see how that would be a wheel and axle. A well pulley system would be another example. So here would be the axle, and then this would be the wheel. And the same thing for a capstan. Okay, so as I mentioned before, there's two different scenarios when you're talking about a wheel and axle system. You can have it where the wheel is turning the axle or where the axle is turning the wheel. So let's think about some examples on when the wheel is turning the axle. When the wheel turns the axle, this right here would be some examples of that scenario, right? So when you turn the steering wheel on a car, your effort force is actually on the wheel, right? So the wheel right here, this would be your effort force. And the axle, which would be somewhere in the middle, would actually be your resistance force. And the same thing for these other scenarios, right? When you turn the knob, you're turning the effort force on the outside. This is the effort force. I can't really read that. Effort force. And then your axle would be on the middle, and the FR would be the resistance force. The same thing for like a valve that would be outside, say to turn something on and off like a water hose, you would turn the knob, which would be your effort force, and then the resistance force would be your axle, right? Okay, so when an axle's turning a wheel, two examples would be a bicycle, right, or a Ferris wheel. So the motor in a Ferris wheel here's your axle and here's your wheel, right? Your effort force is now in the center, whereas the resistance force would be on the outside. And the same thing for a bicycle, right? So the axle is what drives the wheel, and then the wheel is where you have your resistance force. Okay, so when we talk about the IMA for a wheel and axle system, essentially what we're going to be looking at is the effort diameter versus the resistance diameter, right? So let's say I have a wheel and an axle system here, right? And my force effort is on the wheel, and my force resistance is going to be on the axle. Okay, so essentially what that means is that your DR would be the diameter of the axle, and the DE would be the diameter of the wheel, okay? And then your IMA would just be your DE over your DR. But also keep in mind that you can have the other scenario, right, where your wheel is the resistance force and your axle is the effort force, right? In that case, then your axle is going to be your DE and your wheel diameter will be your DR. So it really depends. So the first thing you need to do when looking at a wheel and axle system is decide, is my wheel driving my axle or is my axle driving my wheel? That way you can identify what is your DE and your DR. Okay, so your IMA will be your DE over your DR. Okay, so in this particular scenario, it tells us that the diameter of the axle is going to be 6 inches, and it tells us the diameter of the wheel is 20 inches. So what is the IMA if the axle is driving the wheel? Okay, so if the axle drives the wheel, then our FE is on the inside and our FR is on the outside. So our DE would be the axle, which is 6 inches, right? So it would simply be 6 over 20, and that would give you your answer. Okay, so 6 over 20. And then if the wheel is driving the axle, it would simply be the other way around, 20 over 6. Okay. Okay, and then when we're talking about AMA for wheel and axle system, this one's easy because it's just your FR over your FE. So again, you have to determine, is my axle driving my wheel or is my wheel driving my axle, right? So if the wheel is driving the axle in this scenario, then my FE is going to be the 70 and my FR will be the 200. So this would be 200 over 70. And then don't forget our efficiency equation too. Remember the efficiency equation, which is defined as AMA over IMA. So once we know the two values, then we can determine how efficient the system's going to be. Because remember, IMA is the ideal, the perfect scenario where we do not have friction. AMA is going to be where you have work lost in your system. And you need to compare the two to determine how efficient your machine is going to be. Okay. So in this particular case, we would just plug in our AMA, and then our IMA, remember, is just DE over the DR, and then we would get 85.9%. Okay, and that's it for wheel and axle system.